Hi everyone, welcome back. So in our previous video, we successfully created the data that we are going to need for this supply chain smart contract. So in this video, we are going to create the functions because the functions are going to manipulate this data. So that's why you can't just create a smart contract that has only data, but it has to have functions that we act on this data. So for the sake that for us to move like on a good speed, I am going to grab some of my codes. These functions, I've written them. I'm just going to grab them. Then I'll also explain what each line of the code, I'll try to explain what they do. So the first function that we are going to create is add participant. So this function will enable these users of this application to add a participant. And as you can see, it takes some parameters. It takes a name, a password, an address, and a type. Okay, so anybody calling this function will pass this, will pass arguments to these parameters, and we are denoting them as memory. This is to indicate that we don't want to store this information on the blockchain, but we want to store them locally. So the first thing we do is we increment an ID. Okay, we created a user ID, then we incremented the participant ID. Okay, so we do this for every participant that's going to be added. And the next thing we do is we now take these, the arguments that were passed into this function, and we assign them to the participants. Remember, we created a mapping called participants. Yeah, this mapping called participants. And this mapping it maps a uint to a participant struct. So what that means is that over here, we are actually adding these values to a particular participant. Okay, I hope you understand that. So we remember the participants, we have a struct called participant, and that struct holds different attributes that make up a participant. So the idea is when adding a participant is to add the values that was passed during the call of the function to this struct. So that's what this function is simply doing, and it returns the user ID of the participant that was added. So it simply says to the caller of this function, hey, we added a participant with this ID. So that's the first function. So we are going to add up the second function, and the second function is simple. So it's a good practice to, after adding a participant, you should be able to get a participant. So the next function is get participant, and this is pretty simple too. What happens here is that you pass a participant ID, and it returns the following information about the participant. It returns a string, an address, and another string. So that's what's happening here. It's simply going into the participants mapping. Remember the participant mapping? Yeah, this mapping is simply going into the participant mapping and passing the ID to get to access the attributes with like username, participant address, and participant type. Let's go over to the next function. So this function, we've been able to add a participant using this function and also been able to get a participant. So we also need to be able to get a product. Remember, to get a particular product, we also need to be able to add a particular product and also get the product. So the next function is about adding a product. So as you can see, to add the particular product, it takes some parameters: owner ID, model number, part number, and product cost, and it returns a uint. On line 61, something interesting is happening here, and what that is we want to make sure only a manufacturer can add a product, because in the application, as a manufacturer of a particular product, you should have the right to only manufacturers should have the right to add product. So we need to compare the participant type with manufacturer to make sure it's manufacturer, to make sure whoever is calling this function is a manufacturer. And what we are doing here is simply using kcac because in Solidity you cannot compare strings. Okay, so the only way to compare strings is to convert them into hash and compare those hashes. So that's why we're using kcac to get the hash of the participant type, okay, and compare it with the hash of manufacturer. So that's what we're doing here. And there's another way you can do this. Okay, you can simply use the require statement to make sure that participant type is equal to manufacturer. Okay, but we're trying to explain something about hashing. So what we do here is that we increment a product ID. Since we're adding a new product, for every product that we add, the IDs are going to be different, and we increment them every time. Then after that, we do basically what we did in the add participant function, which is to assign the values that was passed to the products mapping. Okay, so we assign the model number to the model number attribute of the product struct. Yeah, so that's what basically happens here, and we simply return the product ID as before to say, hey, we successfully added this participant with this ID. So so after adding a product, we should be able to get that product. That's what the next function is about. So get a particular product, just like before, it takes a product ID, and it returns the following information. It returns a string, 3 strings, a uint, 32 address, and another integer. So these are all information about a particular product. So it uses that ID and assesses the products mapping to get, passing the product ID that was passed to this function, and using that to assess the different attributes like model number, part number, serial number, cost, product owner, and this information. Okay, we'll stop here for now, and we still have more 4 functions to define in this smart contract, and we'll be done. So in the next video, we are going to define the other 4 functions. Thank you. See you in the next video.